In this video, I will explain you the basic and fundamental parts of Kirchhoff rule. So one thing is Kirchhoff rule, where it will be applied. It will be applied in complex circuited like this, where we can't separate the elements in series and parallel to finally get a simplified circuit. So in such circuits, we will be applying Kirchhoff rule. Okay. Now, so in Kirchhoff rule, three things are very important: junction, branch, and loop. So what is junction? Let's say this is the circuit. Okay. In junction, you will have three directions. Let's say, is this a junction? How many directions are there? 1, 2. Two possibility for the current movement. One in this direction, another one is in this direction. Here, one in this direction, another one is in this direction. But what about at this point? Three directions possible, right? Here also, three directions possible, right? So these two are junction A and B. Okay, so in a junction, what is the necessary conditions? Three directions will be there. Directions. Now, what is a branch? Branch is nothing but continuous element in between two junctions. Now, this is junction A, junction B. So, all the elements, okay, here in this case, if you are going in this way, you have a battery, you have resistance R1, then reaches junction B. So, this is one branch. And this one is another branch. All the elements A till B, continuous elements. So from A till B, we have only one resistance, one branch. This is another branch from one junction to another junction. So this one is between the junctions. All the elements. So it's not for elements, including all the elements. All the way from junction 1 to another junction is a branch. And what is loop? Loop is nothing but take a point. It can be a junction or it can be any other point, and go in one direction and reach back in another direction. That is a loop. For example, from A, I am going through this cell, then one resistance, then here, then another resistance, then the same point A. So it's the same point A. From A I am starting, so I am going to give this point as C. So it's the same thing. There are no resistance connected, right? So point A and point C is the same thing. If there are no resistance, it's the same point. So no need to separately write as A and C. Okay, so I'll keep it as A itself. A, the same thing. So this is one loop. From A, I am going through the cell, through the resistance, and going through B, then resistance, let's say this is R3. This is one loop. And from A, is there another loop possible? Yes. From A through this cell. So this is cell 2, this is cell 1. Through cell 2, through resistance R2, then B, then R3 to the same point. Is there one more possible? Yeah, that is possible. Like in this way. That is from A, then cell E1, R1, B, R2, E2. So what are different loops possible here? I'll make the loops here. So loop 1 from A, that is A, then E1, then R1, then B, then R3, then A back. So from A, I have started, I have ended at A itself. Now loop 2. What is loop 2? From A, I am starting, then I am going to take in this direction. A, E2, R2, then B, then R3, then back to A. So from A till A. You can take in this direction, also in this direction. Doesn't matter. Now one more loop is possible. Loop 3. What is that? From A, then E1, then R1, then B, then R2, then E2, then A. So these are three different loops possible from A till A. So your concept about loop should be very clear. Your concept about junction, that is the point having three different directions, that should be clear. Your concept about branches, that is the continuous element or the continuous path from one junction till another junction, that should be clear to understand Kirchhoff first and second rule. So be clear with all the concepts. In the next video, I will start Kirchhoff first and second rule. Okay, thank you.